Right, today's lesson, we're going to look at water. We call it water treatment and potable water. So first of all, we need to understand what different types of water are possible. And you can see that in red. We have seawater, okay, which obviously come from the seas and oceans. Now that will have a lot of salt in it, so a lot of dissolved substances, a lot of microbes. Then we go to groundwater. Now groundwater comes from streams and rocks, okay, water on underground streams and rocks. So that's going to contain microbes with some dissolved substances. Then we have something called fresh water, which luckily we have a lot of in England. That is rocks from underground streams and rocks, as well as rivers, lakes, ice caps, and glaciers. That will contain microbes, but not so much. They'll be very low. And they'll be very low dissolved substances. So that makes it the easiest one to take water that's safe to drink from. Now, wastewater is obviously water from industry, agriculture, and from your toilets. So a lot of microbes and dissolved substances. And then we have this magical word of today's lesson, potable water, which means water that is safe to drink. Now, that doesn't mean it is 100% pure. So it will still have some dissolved stuff like calcium in it, but very low or zero microbes, nothing harmful to you. And then pure water is essentially distilled water where you just have H2O, nothing else. No microbes, no dissolved salts, no minerals, nothing. So with that in mind, these are the different types of water. We're now going to look at how you make water potable, meaning safe to drink. Really, it depends what you start from. Are you starting from fresh water, seawater, or from wastewater? Okay, so it really depends where you live. So in the UK, as I said, we have a lot of this kind of fresh water and groundwater. So what we need to do is essentially filter it by passing it through a filter bed that's usually made of sand. That's going to remove any large insoluble twigs and any other solids. And then you need to sterilize it. And you have one of these three ways of sterilizing. You can either treat it with chlorine. So you add chlorine to it. But if you use too much, then it's toxic. You can fire ozone at it, O3, or you can fire strong UV light through it, and that will kill the microbes and sterilize it. I'll probably go for the second two bullet points as opposed to the chlorine. And that's how we get our fresh water into potable water in the UK. Okay, so choose an appropriate source of fresh water, pass through a filter bed to remove insoluble solids, and sterilize in one of these three ways. Okay, and that's because we have a lot of rain in the UK. That's the only kind of benefit from our rain. Now, if you're in a country where water supplies might be scarce, like in Africa, we have to get the water from seawater. So there's two ways to do that. We can use simple distillation. So we heat up the water, boil it. It turns to a vapor and it cools and condenses in here. So it cools, it goes up, you heat it, and the desalinated water will drip back. Okay, so after it cools and condenses, you're going to get pure water essentially. Obviously, they'll have no benefits of having calcium in it or any other minerals, but it'll still be pure water. The problem with this is it's a very high energy process because you've got to get a load of seawater and boil it and then condense it. So it boils, rises, cools, and condenses. Okay. Now, reverse osmosis is the other method. Now, reverse osmosis is when you're going, instead of going from a high to a low, you're going from a low to a high water potential. So you apply very high pressure, which unfortunately is also high energy, and then it will push the seawater through this semi-permeable membrane. And this membrane will only allow the water particles to go through, and it will not allow ions or other dissolved substances to pass through. So it's a specialized semi-permeable membrane that only lets water through. And it's called reverse osmosis because normally, of course, osmosis is from high to low, not from low to high. That's why you have to add this pressure. A bit like active transport in biology. And that completes how you can make potable water from fresh or seawater. But now we have to consider how we treat wastewater. So we need to treat wastewater before we release it back into the river streams, before we can then apply this process here. So let's look at wastewater treatment. As you can see, wastewater comes from people's toilets and from industries. The first step, once again, is a type of filtering step. It's called screening and grit removal. So large solid and grit are removed. Then the water will pass into a sedimentary tank. We have a primary one and a final one. So a sedimentary tank is where you let the water settle, and all the kind of organic waste will sink to the bottom here, and the remaining water will be on the top. Now, the top part is called effluent. The bottom part is called sludge, and they undergo different treatment. If we start with the sludge is treated anaerobically. So that means with anaerobic bacteria. Okay, so anaerobic digestion of sludge by bacteria. So this sludge is digested and without oxygen by bacteria. And as a result, it can be used to provide methane that can be used in burners. On the top layer, we have effluent, which undergoes aerobic digestion. So air is passed through it. And aerobic bacteria, which are good bacteria, kill the harmful bacteria. And it passes into this tank here, and it settles again. Any organic waste, once again, at the bottom will be tapped off of sludge, and it'll join the sludge treatment. And when the anaerobic bacteria treat the sludge, they produce methane as a byproduct. And then the methane can be burnt for gas stoves or other heating purposes. The top layer can just be released into the water, into the river. Then once it goes in the river, it'll need filtering again, and then treatment with UV light or chlorine or ozone if you want to drink it. But you have to treat the water first so you don't release toxic stuff, kill the fish, and also you can't have rivers flowing with such toxic chemicals. So that's why you're doing all this. Okay, so in summary, you're filtering it, you're screening it, you're treating the sludge anaerobically, producing methane as a byproduct and burning it. And the top layer is effluent with loads of air and oxygen at it. Aerobic bacteria will then kill the bad bacteria, and then you'll be able to pass it into the river. So that's the summary of how it works. This is obviously in these notes as well, if you want to read through it. As described, the words I used are kind of described here for you and here. And the wastewater treatment is shown for you here. So you see how dirty it is. And it talks about these different treatments. These are the four main stages. So if someone asks you to just summarize the four main stages, you will talk about screening, sedimentation to produce the sewage, sludge on the bottom and the effluent on the top, the anaerobic digestion of the sewage, and the aerobic biological treatment of the effluent. And that's all there is to it. Okay, and this describes in a bit more detail what the biological treatment is and what temperature it's carried out at. Okay, so these notes will be attached. Rusting was done in the previous lesson, so you can read about it here, but it was done in the previous lesson. And this is it. That's how you treat wastewater. Thank you for listening, and see you next time.